Hello, this is Chapter 5 for Business Math called Savings Accounts. We are in Lesson 5.7, Daily Compounding. So we've been doing quite a few different interest calculations over the last couple of lessons. We started with pretty simple interest, then we went to compounding with kind of longer calculations there in Section 5. Section 6 introduced us to kind of this table idea where we're given the number to calculate instead of having to do each period. There's just a certain number we can calculate by. And now we're going to look at daily compounding. Make sure you're looking at the chapter, read through the lessons, pay attention to the examples and how they're using the formulas. What formulas are they using in each example? And definitely we need to be paying attention to the wording at this point. We should definitely be able to recognize the words that they're using as far as when it's being compounded. So daily, monthly, semi-annually, semi-monthly, these should definitely make sense to you at this point because we should be reading through the chapter to make sure we understand what those mean. And then the word compounded too, this is at least the third section that we've used that word. So we should know what that means by now. All right, so anyway, let's go ahead and read the summary here. So the more often interest is compounded, the more potential you have to earn a greater amount of interest. Many banks offer savings account with daily compounding. Know about that. The account will earn interest from the day of the deposit to the day of the withdrawal. A table can be used to calculate the amount and interest for daily compounding. So remember these formulas from the previous lessons. We have amount equals original amount times amount per dollar. So they give us the table. So this is the amount per dollar. If we have 21 days, here's the amount per dollar. If we have 22 days, here's our amount. If we have 140 days, here's our amount per dollar. So we just kind of keep going through the columns here. They kind of moved it over instead of having it stacked straight down, so it didn't take up as much room. And then the compounded interest just simply equals the amount you just calculated, because remember this formula tells us how much is in the account at the end of the period. But if we want to know how much interest we made, we subtract that from what we originally put in. So how much more money do I have now? All right, so this table is also, and I don't know if I still have it open. I do believe I do. So I wanted to show you, this was from Section 6. We just did that a little bit ago. So if we go back one page here, we have amount of $1 at 5.5% compounded daily, 365 days per year. So this is the table that they have there. But if you notice, it's got quite a few more options here. It doesn't just start at 21 and go to 140, and the other one skips quite a bit too. So it doesn't quite have everything in it on the other one. This one goes from 1 to 140, so it's just an expanded version of that table. In case you didn't know it was there, it's in the back of the book in the appendix on page A10. All right. So we're going to go ahead and calculate some of these. We're only going to look at a couple of them. These ones are not super crazy calculations. So we'll kind of go through how to use the table, and then we'll move on to the next section. So Judy Sloan deposited $8,000 at 5.5% interest compounded daily for 25 days. What is the amount in the account after 25 days? How much interest did her money earn? So for the first part here, we have 8,000. That's definitely important because, whoops, ugly line there. There we go. 8,000 at 5.5% interest compounded daily. So this is already 5.5% compounded daily. We don't have to do that same calculation we did on Section 6 where we had to divide the percent by the number of times compounded because this is already kind of divided out for us. This table is already ready for 5.5% compounded daily. So we don't have to do that extra calculation. We literally just go down and we say it's 25 days. So I go down my list until I find 25 days. And there's my number right there. So I go 8,000 times that number, that amount per dollar. And that will give me how much is in her account after 25 days. The interest earned, remember that's this amount in her account after 25 days minus the 8,000 that she put in. That tells me how much she made in that 25 days. Let's see. The next one, Same exact idea. We just have 120 days. So you just want to make sure you go through your list until you find 120 days and use that correct rate there. Let's see. Again, on number 3, let me scooch down here. Boop. So number 3, nothing crazy happening here. Same exact idea. When you're going through. So they do tell you on June 10th, this is what she did, but they don't expect you to pay attention to June 10th and calculate the number. Sometimes they do actually do that. In this case, they just tell you it's 60 days. The June 10th is just a little bit extra information. Let's see. Francesco Delgado has a savings account that earns 5.5% interest compounded daily. On May 5th, the amount in the account was $15,000. How much interest will the money earn in 90 days? So again, May 5th is just extra information. They give you the 90 days here. So let's go ahead and take a look at the next piece. Boom, boom, boom. All right. I believe this is going to be exactly the same. Nothing changing on any of these. We just have to pay attention to the number of days they're giving us. On number 7, this is where they're getting to the point where they want you to pay attention to the dates, okay? So we have on October 1st, Mandy Loya deposited $1,120 in a savings account that pays 5.5% interest compounded daily. On October 22nd, how much interest has been earned on the principal in her account? So we need to be paying attention to how many days are between October 1st and October 22nd. So you just simply need to count the number of days if you were counting. So make sure you don't necessarily count the first day as one. It would be like 0. So October 1st is kind of like 0. And October 2nd, 3rd, 4th, 5th, 6th, 7th, 8th, 9th, 10th. So when you go through and you find the number of days, let's see, it is 21 days, which you could just do 22 minus 1, and that's 21 days. So that's kind of another simple way to do that. It won't work if it's over more than 1 month, obviously. It only works if it's in that month. You may have to do that for each month if it's over a longer period of time. Same thing, I believe, with number 8. It wants you to pay attention to the timing here. So we have March 6th to July 4th. So we're going from March to April to May to June to July. So we're over a 4-month span there. We need to go and maybe look at a calendar and look how many months or how many days are there if you don't know how many days are in each one of those months, and actually kind of add them up. So how many days do we have in March? From March 6th to the 30th. How many days do we have in April? 31st. And then April, same thing. That's going to be the whole month though. And then May, again, whole month. June, whole month. July, though, only 4 days there. Okay. So make sure you're paying attention to that and you want to add all of those up. So I think I'm going to let you guys do that and go through and actually figure out how many days are in between there. And then once you know that, that's where you go on the chart to get your calculations. So let's look at the algebra one here. Boom. So use the compound interest formula from lesson 5.6 to find the interest on $20,000 at 6.55% interest compounded daily from June 15th to October 15th. Okay, so they want you to go back and kind of get that compound interest formula from the last section. So I'm going to go ahead and write it here. The amount in the account will equal principal times, and we go $1 plus the rate divided by time. And then that's raised to the number of times it's compounded over the time. So that's a little bit, not necessarily super complicated formula, but it's, for business math, this is probably one of the more complicated formulas we're looking at. So we want the amount of 20,000. And then we have $1 plus the rate, which is 6.55, divided by the time. So let's see, what time do we have here? Oh, darn it, I didn't write it down. All right, so let's look at this way. So we have June, July, August, September. I don't know why I'm writing them all the way out, September, and then we have October. All right, so June, we start on the 15th, and hopefully we know how many months are in each year. If you don't, go ahead and you look at a calendar. So in June, there's 30 days. So we go from the 15th to the 30th. So that's, remember, when you're counting, you don't go 15, 16, 17. You go 15 to 16. That's a full day. 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30. So make sure you're paying attention to that, because otherwise you'd end up with an extra day there. So we have our 15 days, and I'll go ahead and open. I don't see my, oh, here's my calendar. And you get to see my crazy little dinner time calendars here. So just ignore all those. But we're going to go to, I'm going to go like this so that we can kind of see it a little bit better. So we have 15 and we have 30. So we just counted that. So again, you can count it right on here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So we have 15 days. And then we're going to go to July. Well, in July, we're going to look at all 31 days. I don't need to separate that out. So here, move this over. And again, same thing for August. There's 31 days there. So I don't have to necessarily count those if I just know how many days there are in that month. September has 30 days. And then remember October, so again, I'm going to bring this over. We're only going to day 15 here. So we're going 1, 2, 3, 4, 5, right? All the way to day 15. So we're not taking into account all 31 days of October, only 15 days of it, like that. So the main thing here is you need to kind of know how many days there are in each of the months in order to do this correctly. So we're just going to add these together. So let's see. We get 30 plus 30 is 60, 90, 120, plus 2 more, we get 122. So we get 122 days. All right. Scooch up a little bit here. I'm running out of room a little bit. All right, so let's make sure. I want to make sure when I divide this that it comes out correctly and I'm not fibbing to you guys. I didn't write this part of the calculation down when I went through this. So let's see, we get 6.55 divided by, whoop, oh, 6.55%. That would help. Divided by 122. Let's see, are they working more on a monthly basis? I'm wondering if they're kind of going back to monthly on this one. I think they might be. I might have had you calculate the days for no reason. So this would be 1, 2, 3, basically 4 months. So let's see if that works out correctly. No, not quite. So let's see. Trying to figure out what exactly did they divide this by real quick. That. Oh, hope if I was doing this correctly. Divided by 1, 2, 3, 1, 7, 9, 4, 5, 2. Okay. So they actually divided it by 365 days, like this. And we're going to take into account this 122 on the end here. So we have 122 on the end here. So it's number of times compounded, which would be 1 times the time, which is 122. So that was my mistake. Sorry for the little pause there. I kept trying to divide by 122 and I wasn't quite getting the right number because we needed to do it. We need to divide by the number of times it's compounded for the whole year, which is 365. All right. So now we're back on track here. So we get 1 plus, when I divide these numbers, and remember this is a percentage, so don't forget to put that percentage in your calculator or move the decimal over if you don't have that percent button. So when you divide this, you get this very, very tiny number, which is pretty long, like this, and that's to 122 still. So now we can add these together, these two pieces. I know this is a very long, crazy looking number, but we can definitely add it together. So we have kind of 1 crazy looking long number instead of 1 plus a long number. And we need to raise that to our exponent here. So again, I'm going to show you the calculation here so you can actually see it. So we have 6.55%. Again, if you don't have this percent sign, you need to type it in this way. Divided by 365 equals, there's my nice long decimal here, and I just cut it off after the 2. If you leave it in here, it's actually a little bit more accurate of a calculation. So we're just going to go plus 1 equals, there's my whole number here. And then I'm going to raise it to the power of 122. So I can do that right on the calculator. Remember, this is squared, this is cubed. If I have a number bigger than 3, some calculators actually only have a 2. So you're going to have to go to this exponent here. So x to the y exponent. And what that means is when I click on this, I get to tell it what my exponent is. So my exponent is 122, and I click equals. And this gives me my next number. I'm going to scooch this over. Oops, so actually doesn't disappear behind my paper here. So I have 20,000 times 1.022132. I'll go up to 6 like that. So we want to go pretty far out. In fact, if you don't clear your calculator, if you keep using the calculation from your calculator without rounding, it's going to be a much more accurate calculation. As soon as you start rounding, you're changing the answer just a little bit, but the more money we're calculating, the more it changes. So 20,000, you're going to make a pretty big difference by rounding pretty quickly. But if we're starting to talk about maybe millions, that's a huge difference once we start rounding, especially if we round early in the problem. So be careful about rounding. Because especially if you're rounding up, that means that your amount's going to be too big. If you're rounding down, you're shortchanging yourself. You're taking money away from the calculation. So just be careful with rounding. So the last piece here is we literally just multiply the number that we have in our calculator times 20,000, and that'll tell us how much we have in our account at the end of this 4-month period. And I'm saying 4-month period because it's 3 full months and 2 half months. So it's basically 4 months. So make sure you're paying attention to what they're asking though. They want to know the interest. Find the interest on this amount. So once you know this is how much will be in the account at the end of the 4 months, that's not what they want to know. What they want to know is the interest that you made on the money. So you're going to take this amount and you're going to subtract 20,000 from it, because that'll tell you how much interest you made. This is the answer they're looking for. Okay, so pay attention to what they're asking you to find too. That definitely makes a difference there. Alrighty, so I'm going to let you finish that off. I did quite a few of the calculations with you. Again, I suggest you go through and do these calculations on your phone or on your calculator. Don't just type the numbers in here that I have, because they're rounded. And like I talked about just a second ago, rounding can, change the answer depending on the amount we're doing by quite a bit. So be careful with rounding. All right, well, I hope that helped, and I will see you in section 8.